Want to know how to drop some serious science knowledge at your next party?
Yeah, like how to really impress your friends with the latest scientific discoveries.
Well, then you've come to the right place.
Today's deep dive is going to take us into the world of biomimetic materials
Okay, so biomimetic materials.
and self-healing polymers.
Biomimetic kind of sounds like taking inspiration from nature.
Yeah, exactly.
Oh, I
It's
feel
like,
like it is.
yeah, you got it. It's basically saying, hey, nature has already figured this out, right? You look at a gecko's foot and you say, how does that thing stick to the wall?
How does that work?
Right. And then you try to figure out, okay, well, how can we use that same concept?
So instead of reinventing the wheel, we're just looking at all of nature's best designs.
Exactly. And just saying like, hey, nature's had millions of years to perfect this stuff. Let's just copy it.
That makes a lot of sense.
Right.
So we're talking about materials that can repair themselves like living tissue,
Yeah.
adhesives that can mimic gecko feet, and coatings inspired by the way seashells form.
All that and more.
Wow.
Yeah.
Self-healing materials.
Yeah.
That sounds like it's straight out of a sci-fi movie.
I know, right? It sounds crazy, but it's becoming a reality.
How is that even possible?
So it all comes down to polymers.
Polymers.
Yeah, so polymers, think of them as like these long chains of molecules.
Okay.
And now imagine these chains are designed to break apart and reconnect under certain conditions.
So like those toys that you could pull apart and the magnets would snap right back together?
Yeah, exactly like that. But instead of magnets, we're talking about chemical bonds that reform
Wow.
when damaged, and they essentially heal the material.
So like a scratch on your car could just disappear on its own?
It's not quite that simple yet.
Okay.
But researchers are making progress. I mean, some self-healing polymers can already repair small cracks and scratches.
Still, it's pretty impressive.
Yeah, and the potential applications, I mean, they're huge.
Yeah, like electronics, medical implants. I mean, the list just goes on and on.
Right. And now imagine taking this concept a step further with self-assembling materials.
Self-assembling.
Yeah.
So they don't just repair damage, they actually build themselves.
Yeah, it's pretty wild. So think about peptides.
Like amino acids.
Yeah, those short chains of amino acids.
Okay.
Scientists have figured out how to design peptides that spontaneously assemble into complex structures.
So they're like tiny little building blocks that snap together.
Exactly.
So we can program them to create like specific shapes and structures.
You got it. It's like giving them a blueprint and letting them do the construction work at a molecular level.
That is incredible.
You're right.
I mean, where do we even begin to apply something like that?
Well, think about like drug delivery systems where these peptides could assemble into these tiny capsules that release medication at specific locations in the body.
Oh, wow.
Or you could create biocompatible scaffolds for tissue regeneration,
Oh, that's interesting.
like guiding the growth of new cells.
Like nature and cutting-edge technology are just merging right before our very eyes.
Yeah, that's the beauty of biomimetics. By looking at how nature solves problems, we can come up with innovative solutions to some of our biggest challenges.
So it's not just about copying nature. It's about understanding the underlying principles.
Right.
And applying them in creative ways.
Exactly. And it's not just about self-healing and self-assembly.
Right.
I mean, nature has inspired some amazing adhesives, too. You know how geckos can walk on walls and ceilings?
Right, like those tiny little hairs on their feet that just grip to any surface.
Exactly. And it's not sticky glue or anything like that. It's something called van der Waals forces,
Okay.
which are basically weak attractions between molecules.
So those tiny little hairs can create enough attraction to hold a gecko's entire weight.
Sounds crazy.
That just doesn't seem possible.
But the sheer number of those tiny hairs creates a huge combined force.
Oh, wow.
And so scientists are now developing synthetic materials with microscopic structures that mimic gecko feet.
Interesting.
And these materials have incredibly strong but also reversible adhesion.
So we could have reusable adhesives that stick like gecko feet.
Exactly. Imagine like bandages that stay put without irritating the skin.
Well, that's a good idea.
Or robots that can climb walls.
Robots climbing walls. That's pretty cool.
All right.
I mean, this is already so much cooler than I even imagined.
Yeah.
And we're still just scratching the surface of biomimetic materials.
Oh, absolutely.
Right.
We haven't even touched on biomimetic mineralization.
Oh, we haven't gotten there yet.
That's where scientists are looking at how organisms like seashells and corals build their hard structures to create super durable coatings.
That's fascinating.
Yeah.
But let's hold that thought for a moment and give our listeners a chance to absorb all this incredible information.
Sounds good. Hashtag TTS. The Deep Dive episode 2025, SU204, part 2 of 3.
All right, so are you ready to get back to those bio-inspired materials?
Yeah, absolutely. You were about to tell us about Biomimetic mineralization.
Oh, yeah.
What is that?
So biomimetic mineralization is basically taking inspiration from nature's master builders.
Oh, like organisms, like seashells,
Uh-huh.
corals, even bones.
Oh, wow.
They create these like super strong and intricate structures
Okay.
through this process called mineralization.
So we're talking about like digging up diamonds and using those to build things.
Not quite.
Okay.
Mineralization in this context is, it refers to the way that these organisms use minerals from their environment
Uh-huh.
to create their hard parts.
Okay.
So think about a seashell.
Right.
It's not just like one solid piece.
Right.
It's actually built up layer by layer
Wow.
with this precise control over the minerals and proteins involved.
So it's like they're 3D printing their own shells at a microscopic level.
Yeah, kind of like that.
But how do we mimic that in a lab?
Well, that's the challenge, right?
Right.
So scientists are working on figuring out how to replicate those natural processes.
Okay.
And they're doing this to create new materials with like extraordinary properties.
So what kind of properties are we talking about?
Well, imagine coatings that are self-healing, resistant to scratches, corrosion,
No.
even able to adapt to like changing conditions.
Okay, hold on. Coatings that can adapt.
Yeah.
So like a chameleon changing its color.
Well, not quite color changing.
Oh, okay.
But think about coatings that could adjust their porosity or permeability depending on the environment.
I see.
So that could be huge for things like filters or membranes,
Right.
where you need precise control over what passes through.
It's just amazing how nature already has all the solutions figured out.
I know, it's pretty cool.
All the problems that we're trying to solve.
Exactly. And the beauty of biomimetics is that it's not just about copying
Right.
what nature does. It's about understanding the underlying principles and
Yeah.
applying them in like creative ways.
Okay.
So we might not build a bridge exactly like a spider web,
Right.
but we can learn from the way that those silk fibers are arranged
Oh, okay.
to create, stronger materials based on those same principles.
So it's like we have this whole library of nature's blueprints at our disposal.
Yeah, exactly.
But what are some of the challenges in taking those designs and actually creating technology from them?
That's a great question. One of the biggest challenges is scale.
Okay.
Nature builds things atom by atom,
Right.
molecule by molecule.
Uh-huh.
Trying to replicate that precision at a larger scale
Right.
can be really difficult and expensive.
Yeah, so it's one thing to understand how a seashell forms in the ocean,
Yeah,
but it's a whole other thing to manufacture materials with that same level of detail.
exactly. And then there's also the challenge of, making sure that we're producing these bio-inspired materials in sustainable and environmentally friendly ways.
Right, we can't be destroying the planet in the name of progress.
Exactly. We don't want to solve one problem by creating another.
Exactly. But it seems like even though there are all these challenges, the potential is just enormous.
Oh, it definitely is. And the field is advancing like crazy.
That's great.
Like, we're seeing breakthroughs all the time.
So what's like a really exciting area of research right now?
One area that I'm really excited about is the development of biomimetic adhesives.
Oh, yeah, we were talking about the gecko feet
Yeah.
earlier. But there were so many other organisms that stick to surfaces.
Exactly. Like, think about mussels.
Oh, yeah, those things just cling to rocks, even when the waves are crashing over them.
I know, right? It's crazy how they do that.
How do they do that?
So mussels produce these incredibly strong adhesive proteins that can bond to almost any surface,
Wow.
even underwater.
And scientists are trying to replicate this.
Yeah, they're studying these proteins to create biocompatible adhesives that could revolutionize things.
Like what kind of things?
Everything. I mean, from surgery to underwater construction.
Oh, wow. So you're saying we could fix a broken bone with muscle glue instead of metal plates and screws?
It's definitely a possibility.
That would be amazing.
I know, right? And imagine using these adhesives in places where, like, normal glues just wouldn't work.
Right.
Like underwater repairs or even in space.
Wow, the possibilities are really endless.
It's pretty amazing.
So we've gone from self-healing polymers to self-assembling peptides, bio-inspired coatings, and super strong adhesives for muscles.
And that's just the beginning.
Nature really does have a solution for everything.
It really does seem that way.
Well, this has been a lot of information.
Yeah, it has.
So maybe we should take a quick break and let our listeners catch up.
Sounds good to me. Hashtag TTS, the deep dive episode 2025-0204, part 3 of 3.
All right, so we've talked about self-healing polymers, muscle-inspired adhesives. It's clear that biomimetics is a total game changer.
It really is. And, the more we look to nature for inspiration, the more incredible solutions we find.
Yeah, that's so true.
We've been talking about like mimicking specific structures or materials,
Right.
but what if we could replicate entire biological systems?
Whoa, hold on. Replicate entire systems. Now that sounds like something straight out of sci-fi movie.
I know, right?
Are we talking about like creating artificial organs?
I mean, that's definitely one possibility. But think even bigger. Like, what if we could create self-regulating systems that mimic how a forest ecosystem works,
Okay.
or the complex interactions within a single cell?
Okay, now you're really pushing the boundaries of my imagination.
It's pretty wild.
How could we even begin to recreate something as complex as a forest ecosystem in a lab?
Well, it wouldn't be easy, that's for sure.
Right.
But by studying those systems, we can learn so much about how nature manages resources, how it adapts to change, and how it maintains balance.
I see.
And then we can take those principles and apply them to things like creating sustainable cities,
Oh, that's interesting.
self-sufficient energy grids, new forms of agriculture.
So it's like we're not just borrowing tools from nature, we're trying to understand the whole operating system.
Exactly. And the more we learn, the more we realize how much we don't know.
Yeah, that's true.
Biomimetics is a very humbling field in a lot of ways.
Right.
It forces us to acknowledge that nature has been solving these problems for millions of years, and we're just starting to catch up.
It really makes you wonder what other incredible solutions are out there, just waiting for us to discover them.
Absolutely. And that's what's so exciting about this field. It's constantly evolving
Right.
as we uncover new secrets from nature's playbook.
I can't wait to see what the future holds.
Me too.
This deep dive has been absolutely incredible.
It really has.
We've gone from self-healing polymers to self-assembling peptides, bio-inspired coatings, super strong adhesives, and even talk about the possibility of replicating entire biological systems.
It's mind-blowing when you think about it.
It really is.
And it all comes back to that idea of learning from nature to create a better future.
Well said. So for our listeners, here's a final thought. If nature has already solved so many of the challenges that we face, what other brilliant solutions are out there just waiting to be discovered? Keep exploring, keep questioning, and keep looking to nature for inspiration. You never know what amazing breakthroughs might be just around the corner.